Let's show the process of identifying the basis for the range and the rank of this linear transformation defined by these two matrices here, specifically 2 by 3 matrices. The basis of the range is actually equivalent or equal to the column space of said matrix. We can do that by coming up with a reduced row echelon form of these two matrices here separately, of course, and then once we identify the pivot columns or the columns with the leading one on our initial matrix, the said or the corresponding column is or comprises the column space, which is equivalent to the basis of the range. And then the rank, being a dimension of the range or the dimension of the basis of the range, will then be identified further. So again, let's start with coming up with the reduced row echelon form of this matrix here. We of course already have 1, -1, 2, 0, 1, and 2. The reduced row echelon form strictly shares that once our column contains a leading 1, all the other entries of the said column will be 0. Our first column already contains leading 1, and this is already 0, so no need to manipulate that. What we can look here is, since this here is also a leading 1, this one here, the other entry on that column, which is -1, should be 0. And with that, we can simply add row 2 and row 1 for a new row 1. Okay? Therefore, we'll have here, this is 1 and 0 because 0 plus 1 is just 0. 1 plus -1 is 0. 2 plus 2 is 4. This is still 1 here. This is still 2 here. Even if you have entries here which are non-zeros and non-leading ones, it's already okay because this is already a leading 1 and that's already a leading 1. Hence, just by one step, we're able to identify here the reduced row echelon form of the first matrix A. From this, we could see that column 1 and column 2 contains leading ones, and these are actually pivot columns because these are your pivot positions, the positions assigned by your leading ones. In short, on our initial matrix or original matrix, the corresponding column here and here comprises the column space, being the basis of the range of T. In short, the basis for the range of T here comprises the columns with the leading one on our initial matrix. So initial matrix, you have 1, 0, and the second column is -1 and then 1. Close that. Or you could rewrite this in the form of a vector. You will have here 1, 0, and a -1 and then 1. By the way, before we proceed and of course go to our second matrix, the basis of the range here is just one of the possible bases. This means we could also get another basis using row space. But here we use here the column space, and identifying one is already enough. That's why we use this here. Now that we are done with the basis of the range, we can identify the rank of T, which is again equal to the dimension of the basis of your range. In short, how many vectors or how many elements are there in a set of basis of range of T. In short, the rank of our first matrix is 2, since there are 2 vectors here, or there are 2 elements on that said set. This is how we show the basis for the range and the rank for the first matrix. Let's proceed to the second, as again our goal here is to come up with a reduced row echelon form. Let me copy here 1, -2, 1, 0, 2, and 1. Of course, our first column already has leading 1, and since the other entries of the said column is 0, we don't need to manipulate that. What we could do here is to make this next entry be equal to 1, so this would be a leading 1 by multiplying row 2 by 1/2 for a new row 2. This means we have here 1, -2, and 1, 0. The positive 2 becomes 1, the positive 1 becomes 1/2. Since this is already a leading 1, what needs to be done here is to make this 0. Going to our third column, no need to make this leading 1 or 0 because we are the said row already has a leading 1. Okay, again, let's make this 0 by multiplying 2 to our row 1, sorry, that's row 2 rather, plus row 1 for a new row 1. Hence, we'll have here on our second row, this is still 0, 1, and 1/2. This is still 1 because 2 times 0 is just 0 itself. 2 times 1 is positive 2 times negative 2, 0. 2 times 1/2 is 1, plus 1 I have here 2. Okay, so this now comprises our reduced row echelon form of the second matrix. Then we identify here the pivot columns, and those are the columns with our we have here with what you call this one, leading ones. In short, the corresponding columns on our original matrix or initial matrix comprises the column space, which is just the same as the basis for the range of T. This is again a set containing the two columns, the first and the second. You will have 1, 0, and you have negative 2 and 2. Or you could have here 1, 0, negative 2, and 2. This means the rank of T being the dimension of our range, and our range here contains two elements or two vectors. The rank of T for the second matrix is also 2. The rank, these two bases for our range. So again, this is how we show the basis of the range and the rank for these 2x3 matrices. The goal is again coming up with a reduced row echelon form of the corresponding matrices. Thank you very much for watching.